So now we're going to go through lesson 3.8. So what we're going to do here is we've only found equations of lines knowing that initial starting point and knowing what that rate of change is going to be. Now we're going to change it slightly. Maybe we don't know that initial starting point we have. Can we still find the equation of the line? Can we find the y-intercept? We're going to learn about something called point-slope form. So to do that, we're going to start working with a gala. So we're going to put a event together, and we find a banquet hall to hold the event. And we're told that if we have 150 people attend, the cost is going to be $6,500. If we bump the number of guests up to 200, then our bill is going to go to $8,500. So if we make the reasonable assumption that the relationship between the number of people and cost is linear, do we have enough information to find a model, or basically an equation? So it's reasonable to assume that the cost is, or the relationship between number of people and cost is linear, because it should be the same amount per head. So we do have an appropriate model, because remember, the only thing we need to make a line or graph a line even is 2 points on it. So yes, we have enough information to model the cost since we have 2 points on the line. So we might not be able to write the equation of the line right now, but at least we know we can graph it. So we need to figure out which quantity should be independent, which should be dependent, because that will help us up with setting the line, setting up the equation of the line. So in this particular instance, you want to think, does the number of people depend on the cost, or does the cost depend on another number of people? And it's going to be that second instance because it's a fixed amount per head. Once you know how many guests are going to attend, that's going to tell us what the cost is for our event. So an increase in guests makes the cost change. So the number of guests is our independent variable. And the cost is our dependent variable. So when we go to create the equation of the line, this will tell us what we should have on each side of the equation. So the cost will be the output, and you'll input the number of guests. So now let's go ahead and find the slope of the line we have based on those 2 points of information. So we know, we're told, when we have 150 guests, the cost is going to be $6,500 for the venue. If we bump it up to 200 guests, the cost is going to be $8,500. Okay. So remember, we use the letter M to represent our slope. We look at the difference in the y values. So if I put the 8,500 first, the 200 has to go first in the bottom, because we keep the like points together. And then we subtract the second point, so 6,500 and 150. So these 2 points go together. So up top, we get 2,000. In the bottom, we get 50. So if you go ahead and divide this, you're going to get 40. So what this means is it's that rate of change. For every extra guest we add, the cost is going to go up by $40. So the cost increases by $40 for each additional guest. Okay. Now, kind of the question here is, can we find the equation of the line? We have the slope, but we don't know that y-intercept. I can't just assume it starts at 0 because it might not. Because in reality, I might actually have some fixed costs that I have to pay the venue from the get-go. So we need to figure out what the value of the y-intercept is. So we're going to do this in a couple different ways. The first one is we've got to put a bunch of different variables down and their meanings. So we're going to let x be our independent variable. So this is going to be the number of guests. Y is our dependent. So this is going to be the cost. And the equation of our line is always y equals mx plus b. But we figured out what m is already. We know m is equal to 40. So what we can do is we have y is equal to 40x plus b. This value of b is our only unknown. The x and y are going to stay as variables because those are constantly changing. But that fixed cost isn't going to. So what we're going to use is we know one of the points that has to be on this line. When we have 150 guests, the cost is going to be $6,500. So instead of our x, I can plug in 150, and the y value corresponding to that is going to be 6,500. And this will allow us to solve for b. So when we plug that in, we'll get 6,500 is equal to 40 times 150 plus that value of the y-intercept. So that's 6,500 is equal to 6,000 plus b. So if we want to solve for b, we go ahead and subtract 6,000, and that tells us that b is equal to 500. Okay. So our y-intercept is going to be the point when you have no guests, the cost is still $500. So what that means is 0 guests still cost $500. So this is the fixed rate, the venue cost. Or you can think of it as the flat fee to book the venue. Okay. So now we actually have the equation of our line. We know the value of b. Y is going to equal m, which is the slope, times the variable x, plus the value of the y-intercept. So we have the equation of our line. Okay. So this is one way we can go through finding the equation of the line, knowing 2 points. You still find your slope because you only need 2 points to find the slope. We're going to plug that into m, into our equation y equals mx plus b. And then I'm going to use the fact that we know one of the points to substitute y and x and solve for b. And then we can get the equation of our line that way. Okay. So let's go ahead and graph the line that we found. The y was equal to 40x plus 500. And we're also going to graph the 2 points, which was 150, 6,500, and then 200 people was 8,500. So I'm going to plot the 2 points first. When we have 150 people, the cost was going to be 6,500, and 200 people is 8,500. Now I'm going to go ahead and plot the line like we normally would. We start when we have no guest at $500, and then it's going to go up by 50 each time. So we go ahead and we connect all the dots together, and this is the graph of our line. Okay. So if you did go ahead and plot this without those 2 points, or if that line didn't go through the 2 points, you knew you would make a mistake either with the equation or the graph. It's got to go through both of the points. So the line needs to go through both points. So if it doesn't, we've made a mistake. So now we're going to go about this in a different way. We're going to use that concept of generalizing the problem. We know that for this particular example, regardless of the 2 points I picked, so if I picked any other ones that fall on this line, this slope always has to equal 40. So the slope of the line connecting any 2 points is always going to be 40. So what we're going to do is we're going to call one point on the graph xy. So it's arbitrary, it's xy. We're going to find the slope between this point and this 160, 6,500. So remember, to find the slope, you look at the difference in y's. So I'm going to start with y over x, because these 2 points go together. And then I'm going to subtract the y value for the other point, which is 6,500, and the x value for the other point, because these two go together. And now this is the slope. We know this has to equal 40. Okay. So this is going to be another form we're going to lead to if we multiply both sides of this equation by the denominator. So we have y minus 6,500 over x minus 150 equals 40. If we go ahead and multiply the left side by the denominator, those would cancel, which means we have to do exactly the same thing on the right-hand side. So what we'll get is y minus 6,500 is equal to the slope times x minus 150. So this is called our point slope form. The slope is right here, and then you have a point. So you take y minus the y coordinate of the point, x minus the x coordinate of the point. So you do really instead only need to know the slope, and you need to know 1 point on the line, and that will be enough for you to create it. So instead, if I was given kind of a different version of this problem, maybe I didn't know 2 points, I just knew a single point, and I knew that it was going to be $40 per person. Then I would know the slope is 40, and I could use this form to find the equation of the line. But if you're given 2 points, you can absolutely go through what we did in the prior couple pages of plugging it in and solving for B. So if we go ahead and now solve this equation, you're going to see we'll get exactly the same one we got in slope-intercept form. So we have y minus 6,500 is equal to the slope, which is 40, times x minus 150. So before we can solve, we've got to distribute out this 40. So that gives us 40 times x, and then 150 times 40 So this is y minus 6,500 is equal to 40x minus 6,000. So if we want to solve for y, we'll just add 6,500 to both sides. So that gives us y is equal to 40x plus 500. So this is the exact same equation. Okay. So both of them are going to work. You can do whatever method you would prefer. Okay. So this is our point slope form. X and y are always going to be variables. M is our slope, and then this point x naught, y naught is just some point on the graph, okay? So you're going to take y and you're going to subtract the y coordinate of the point. That will equal the slope times x minus the x coordinate of the point. That is our slope-intercept form. So if you look at this example, you have the point 2, 7. This is our slope 3. So this 2, 7 is the point x0, y0. The equation of the line would be y minus the y coordinate of the point is equal to the slope times x minus the x coordinate of the point. Okay? So now we're going to go through the group portion together. So we're told a small business has been selling 200 digital locking cookie jars per week, which has led them to losing $150. So basically we have a net profit of negative $150. According to their business plan, their net profit will increase by $12 for each unit sold. So what evidence do we see that would lead us to conclude this is a linear relationship? So the idea is that rate of change is constant. The profit is going to increase by the same amount regardless of how many units you sell. You get $12 for each unit. It doesn't change after you've sold the 100th jar versus the 1,000th jar. They both still only give you $12 in profit. So this is our key. So the profit increases by a constant of $12 for each unit sold. So there is a linear relationship between the profit and how many cookie jars we sell. So in that case, the profit depends on how many cookie jars. So our independent variable is going to be the number of cookie jars we sell. And the dependent is then going to be our profit. Okay. So the profit depends on the number of cookie jars. So now we want to see what is our slope going to be. So now you can kind of see here, I only know one point. I only know if I sell 200 cookie jars, I'm going to get $150, or I'm going to lose $150. I don't have another point which tells me how to find the slope. But I do know that the profit increases for each 1 unit sold. So that's going to be exactly our slope. The slope is $12 because it's the rate at which the profit increases. Per unit sold. Okay. So like in the last one, it went up $40 per customer. When we dealt with the snow cone, the profit was 63 cents per cone. It's that unit rate that we're changing by. So now I know the slope is equal to 12 and I have a point on the line. we can go ahead and write this equation in slope-intercept form. And you can do this in either way, but we know the slope is equal to 12. And the point we're given is when we sell 150 or sell 200 cookie jars, the profit is negative 150. So you can use point slope form. You can use y equals mx plus b to go ahead and solve for it as well. So I'm going to do this version. The y is negative 150. The slope is 12. And the x value corresponding to negative 150 is 200. And this value of b is unknown, but now we can go ahead and solve for it. So that's negative 150 equals 2400 plus b. So if we go ahead and solve for b, you subtract 2400 from both sides. And that gives us negative 2550 is equal to b. So the equation of our line is y equals 12x plus b. So it's negative 2550. So our y-intercept is 0, and then the value of b, negative 2550. And what that means is if we sell 0 cookie jars, the profit is negative 2,550. So we're missing out on a lot of money by selling no cookie jars. Okay. All right. So we answered this question. Don't know why it repeated. That's okay. We want to see how many cookie jars do we need to sell to break even. What's the significance of the point on this graph? And then think about what the profit would actually have to be. So our profit is going to be $0. And the equation we have for our line is 12x minus 2,550. So if our profit is nothing, that tells you the value of y is 0. And we want to solve for the number of cookie jars, which is this value of x. So I need to solve this equation to see what number of cookie jars we have to sell. So if we want to solve for x, we'll begin by adding the 2,550 to both sides. So this gives us 2,550 equals 12x. So to find x, you go ahead and divide by 12. And that gives us x is equal to 212.5. So this is the point when x is exactly 212.5, the y value is 0. So you need to sell 212.5, but you can't sell half a jar to break even. And the idea is this value of y being 0 is where you're going to hit the x-intercept. So if you look back before, when x is 0, that gives you the y-intercept. And the reverse here, when y is 0, you get the x-intercept. So you're always going to set the opposite variable equal to 0 to find your intercepts. So this is the x-intercept. Okay. And now you can't exactly break even because you can't sell half a jar. So we can't exactly break even. Because we can't sell 0.5 of a jar. But if we sell 212 or 213 will be close to breaking even. So let's use our equation to fill in these table of values, and then we're gonna go ahead and graph our equation. So our line is y is equal to 12x minus 2,550. So when you plug in x equals 0, the y value is negative 2,500. Negative 2,550. If you plug in 200, that's the point we were given. Our profit is negative 150. If you plug in 400 for x, you're going to see the y is 2,250. And then 600 will give you 4,650. So to create our graph, we're going to put the number of units or number of jars we sell on the x-axis, and on the y-axis we're going to get the profit. So let's go ahead and zoom in. Here is going to be 0. I'm going to make each of these kind of go up by 250. So here's 250 jars. So this would be 50, 100, 150, 250. So we're going up by 50 for each line. This would be 500 jars. This would be 750 jars. And then our profit, let's go ahead and go up by 2,500. So we have some negative profits. Then we go to positive 2,500, positive 5,000. So we need to make sure we can get this 4,650. Make that 4 a little bit easier to see. Okay, so now we've got to go and plot the points. Our profit for 0 cookie jars is negative 2,550, so it's a little bit less. When you sell 200 cookie jars, we're at negative 150, which is around here. When we sell 400 cookie jars, which would be this point here, so it'll be up by 50, so 300, 350, 400. Our profit is 2,250, so that's going to be close to the 2,500. And then finally 600 jars, here's 550, 600. Our profit is going to be 4,650, so close to here. Okay. So the equation of our line just connects these dots. Again, it's not going to be perfect, but that's okay. And here is the equation of our line. Okay. So we want to see how many units do we need to sell to make a profit of at least $500 per week. So what we want is we want the profit to be greater than 500. We need the Y value to be greater than 500. Okay. So kind of at this point, that's going to be right around here, 500. Okay. So we know an exact equation for the profit. We need 12 times the number of jars we sell minus 2,550 to be greater than or equal to 500. So we have to solve this inequality. So we go ahead and isolate the variable by adding this constant over. So that gives us 12x is greater than or equal to 3,050. So to solve for x, we divide by 12, and that gives us x is greater than or equal to 254.2. So to make at least $500, you need to sell at least 255 cookie jars because you can't sell 0.2. So we need to sell at least 255 cookie jars. Okay. So now we're going to switch. We're going to work with a different problem. A custom shirt shop charges a setup fee plus an additional fixed amount per shirt. We know when we order 20 shirts, it's going to be $188, and then 25 shirts will cost us $228. So again, this is going to be linear because there's that fixed amount per shirt. So that's our key. The fixed amount per shirt tells us this is going to be a linear relationship. Our independent is going to be the number of shirts we order. And then the cost depends on the amount of shirts. So we want to see what is the slope and what does that mean. So we have 2 points. When we buy 20 shirts, the cost is $188. When we buy 25 shirts, the cost is $228. So our slope is going to be the difference in the Y values. So 228 minus the other Y value over the difference in X's. So 25 minus 20. So we get 40 over 5, which is $8. So it costs $8 per extra shirt we order. Okay. So now we can find the equation of the line. We've got the slope. You can use point slope form. You could use the y equals mx plus b to solve for b, whatever you'd prefer to do. I'm going to go ahead and use point slope since we already did one using y equals mx plus b. You take y, you subtract the y coordinate of a point. That's going to equal the slope times x minus the x coordinate of the point. So our slope is going to be 8, and you can use any of the points. We know when we sell or when we buy 20 shirts, the cost is $188. Okay. So this point is x0, y0. So we just go ahead and plug everything in. We take y and subtract the y coordinate, which is 188. This is going to equal the slope times x minus the x coordinate, which is 20. So we just need to solve this equation for y. So to do that, we've got to distribute the 8 out. So we get y minus 188 is equal to 8x minus 160. So go ahead and add 188 to both sides. And that gives us the equation y is equal to 8x plus 28. So the y-intercept is exactly this value, 28. So it's the point 0, 28. And so 0 shirts cost us $28. So this tells us the setup fee is $28. Okay. So let's go ahead and graph this equation. We've got y is equal to 8x plus 28. We have the 2 points. You go through 0, 28 shirts. When you sell 20 shirts, it's $188. So let's go ahead and keep it kind of simple. On the x-axis will be the number of shirts. On the y-axis is going to be our cost. So 0 shirts, let's make each one of these worth 4. So here's 4, 8, 12, 16, 20, and then this one would be 24. So each one of these lines is going to be 1. And now our cost, we need to go up to $188 for 20 shirts. So let's make each of these, probably 10 should be good. So here's 10, 20, 40. This would be 60, 80, 100, 120, 140, 160, 180, and then 200 would be all the way up here. So filling in what we know, 0 shirts is $28. So since each one's 10, it's close to the $30 mark. When we sell 20 shirts, the price is $188. So that will be a little after the 180 mark, close to the 190. And our line connects these two. So that is the graph of our line. All right. And then finally, the last thing we want to do is just answer some questions. We want to figure out how much would 35 shirts cost. So y is equal to 8x plus 28. So if we're getting 35 shirts, that's our value of x. So we plug in x is 35, and then we add 28. And if you go ahead and do that multiplication and addition, 35 shirts would cost you $308. And now suppose we want to order at most, or we want to spend at most $500. We want to figure out how many shirts would we have to order. So we want this 8x plus 28, which is our cost, to be at most 500. So we just need to solve for it. We start by subtracting 28. So that gives us 8x is less than or equal to 472. And then go ahead and divide by 8. And that gives us x is less than or equal to 59. So if we want to spend at most $500, we can order at most 59 shirts.